before we get started, let people join. I'll go ahead and introduce myself. My name is Claire. I work at Proctor Sales. Been doing commercial sales for about 6 years with Proctor. And today we'll be chatting about the CaptiveAire DOAS line specifically. We have two guys here from CaptiveAire, Andrew and Ian, and I'll let them introduce themselves a little bit more in a minute. But you can, I'll put my contact information in the chat, so you'll have that, and feel free to reach out to me with any questions that you have. And I will get back to you as soon as possible, and we'll get your questions about the CaptiveAire DOAS line answered. So I'll let Ian go ahead and introduce himself.
Sure. Thanks, Claire. And good afternoon, everyone. My name is Ian Marshall with CaptiveAire. Also on the line is Andrew Moreno with CaptiveAire in my office. And we work specifically on our DOAS product line, which is something that might be a little bit different than what people historically think of with CaptiveAire in terms of CaptiveAire being a kitchen ventilation hoods manufacturer. So yeah, like Claire said, we wanted to kind of just go through and give kind of a basic rundown of the DOAS product line, and just go through some of the features and the options and applications and all that kind of stuff. And I'll kind of treat this from sort of a high level, and just sort of go through the basics, but we can answer kind of any questions. Feel free to cut us off at any point also if you would prefer to go down certain paths, or feel free to put questions in the chat too, whatever works for us. So do you think we should get started, Claire, or wait a couple more minutes?
Let's go ahead and get started, and then yeah, like he said, put any questions in the chat and I'll do my best to respond to you as we're going through.
Great. Sounds good. Okay. So the CaptiveAire Paragon DOAS is a product that Proctor reps, and the Paragon is sort of the naming convention of the DOAS line, but it's pictured here. It's just generally a packaged rooftop or outdoor mounted DOAS RTU, and I'll get into kind of some of the specifics here. Just some quick background on CaptiveAire as a manufacturer. We were founded in 1976. And it's a privately held company with close to over 2,000 employees now, where a lot of that is actually tied up in manufacturing, with 6 plants across the U.S. I think people know CaptiveAire name historically from the kitchen ventilation side of things, with kitchen hoods and exhaust fans and fire systems and that kind of stuff, where this product line, the DOAS, it definitely has its applications for the kitchen makeup air side of things, but it goes well beyond sort of kitchen ventilation world. So get into some of that in more detail here. So yeah, we've kind of evolved from a kitchen ventilation company to a ventilation technology company, with the product being launched for beta, about 6-7 years ago. So with that, CaptiveAire, all of us are, engineers, so we are kind of focused on trying to provide the best outcome. So, a lot of times with Proctor, we'll be asking you guys a lot of questions and trying to just get some of the nitty gritty details of jobs, just ultimately trying to provide sort of the best application or best outcome. As with this product, it's a lot of application engineering and very some kind of it's not necessarily a one size fits all type of product. It's very built to order, and there's a lot of kind of unique and specialized options and that kind of stuff. So we'll definitely be pretty involved on the design side as well when we can be. In 2022, the company as a whole did about 750 million in sales, and that's just company wide, just to give you some sort of perspective of the size of the company that's in the realm of a company like Aon. So just to kind of give you some background on, the size and some of the resources that we have available as a manufacturer. So why is DOAS used, or what really is DOAS compared to what someone might define as like a traditional RTU or rooftop unit? Um, Generally, rooftop units or RTUs are less so geared towards conditioning outdoor air, where DOAS, or this unit in particular, is catered towards handling higher volumes of outside air, up to 100% outside air. So with kind of the way that designs have been going, we see a lot of what they call kind of decoupling the sensible and latent loads, or just kind of decoupling the outdoor air ventilation loads from the internal space loads. So a lot of the times, we'll pair with VRF systems or fan coils, or something along that nature, to essentially have the DOAS be handling the outdoor air distribution for the space, and the other equipment handling the recirc heating cooling needs of the space. Not to say that our DOAS unit can't run as a high outside air or high recirc type unit as well, but that's typically how DOAS is handled because of the humidity loads from the outdoor air. It's a good design approach to kind of separate that with a dedicated unit for the outdoor air loads. So not so much, I guess, in the northwest of the country, but in general, that the outdoor air loads have a large humidity load, and even in the northwest, that still is at play, to consider humidity loads. And even in places that we think of a traditionally drier locations in the country, there is still considerable amount of latent or humidity that needs to be considered when you're talking about processing outside air. So this chart kind of just shows a different breakout of latent versus sensible cooling ton hours per year, to just show sort of how that latent or humidity removal is a demanding and energy intensive process, which is why DOAS is utilized. So for applications, we really get involved in a wide variety of things. This is just a small list of what we see, but a very common or popular DOAS application would be a hotel corridor pressurization, or apartment or senior living, where we're pressurizing the corridors and bringing in the ventilation that way, and then each individual guest room or hotel room has its own kind of individual heating cooling unit. So again, a space that requires a high volume of ventilation. We get involved a lot with hospitals and labs, where they need high volumes of ventilation, and in many cases very tight and precise temperature and humidity control, which is what the DOAS has the capability of doing. Grocery applications require pretty low dew points. Schools obviously are heavy on the ventilation side. Kitchen ventilation, again, something that CaptiveAire is familiar with, but it's a small portion of the jobs that we kind of get involved with this product line. We do get involved quite a bit with grow facilities, where the conditions within the space they're bringing in 0% outside air. They're running full recirc, but the conditions within the space require cooling and dehumidification 24/7 year round, and you need to be able to run DX cooling and dehumidification, even at extremely low and cold outdoor air temperatures because of the conditions in the space. And we have special options and logic to accommodate that. Casinos, pool rooms, really any application that requires ventilation, which is pretty much any commercial building by code is required to have ventilation. So we kind of see a wide variety of different jobs with that. So this is just kind of a simple diagram of the hotel corridor application that we see very commonly. So we essentially are pressurizing that corridor with 100% outside air, and each individual guest room would have negative pressure in it from a bathroom exhaust. So essentially that corridor is positively pressurized and each room is negatively pressurized. So you're bringing in the ventilation through the door or through a grill in the space. And those individual spaces have their own kind of heating cooling units like PTAX or what it might be. And essentially we're providing neutral supply air to the space continuously. So it's a very kind of simple, straightforward, and really common application we'll see with DOAS. And again, many of these spaces have multiple floors. We have the capability to do space temperature averaging throughout multiple different floors if needed. Same on VRF, or when we're talking about like terminal units where we're kind of providing the neutral ventilation air, and each one of those individual spaces could be doing their own heating, cooling loads, and we're just providing that simple dedicated fresh air for the space at a neutral 70 degrees at 50% RH or so. So the big things that make a DOAS different in terms of components to, say, a traditional rooftop unit, and the big things that kind of make our DOAS unique in the sense is the first component is the indoor DX evaporative coil. We utilize a much wider or larger coil design. So you can see here, this is a 7-row coil, which is standard. We use somewhere between a 4 to a 10-row coil, just depending on the unit size. And the idea of that is to essentially pull out as much moisture as possible from that outside air, because you could be pulling in really hot or really humid outdoor air. You need to be able to cool it down and dehumidify it. And the idea being have as much resonance time in that coil to drop the temperature, to get air to touch every surface. So we use this staggered coil design to essentially pull out moisture, and there's no straight pass through for the coil. So that air is kind of forced to be turbulent and get touch as much surface area of the coil as possible. And then we utilize the hot gas reheat coil in many cases to reheat that air back up. So that's the first component. The second component would be the compressor. Obviously with DOAS design, you're designing around the peak design condition, which happens, maybe a few days a year. And you need to be able to accommodate and hit the required leaving air temperatures at that peak design condition. But the vast majority of your operating time is at, a swing season day or a more mild condition. So we standardize with an inverter scroll compressor, which is a true variable speed compressor. So it has modulating capacity. So it has the capability to ramp up to 100% capacity, but it's tied to a VFD, and we actually can slow the speed down of that compressor to modulate with the outdoor air loads, which are obviously changing on a day by day and like hour by hour basis. So that improves the level of control of the outdoor air, as well as improving the energy efficiency, because it is a true variable speed compressor. So with some of the components that we utilize, we standardize across the board in our DOAS unit with all what we would define as kind of high efficiency or variable speed, fully modulating type components. So where a lot of our competition might have a low efficiency, high efficiency option, we would be standardizing in what would be defined as sort of the high efficiency or HE option with all of our components, and that's standard on all selections. So all of our fan blower options are all direct drive. We don't have any belt driven fans in the unit. For the supply blower, it's a direct drive ECM or direct drive with VFD. As I mentioned, the compressor, it's all inverter scroll compressors. So it's true variable speed with a VFD tied to control the speed. All of our heating options are all fully modulating. So whether it's indirect fired or electric or heat pump, all variable speed. We use an electronic expansion valve, not a thermal expansion valve. Our condensing fans are ECM fans standard. And we use a fully modulating hot gas reheat. So just to name kind of a few of the components, again, we don't offer, fixed staged components or staged heat options. It's all variable speed. So with that, we get, quite a bit of energy savings on the cooling compressor side, because again, that compressor is tied to a VFD. So when we're looking at controlling to a space temperature, we're able to control to that temperature in a much more precise manner because of the variable speed compressor. And with that, you get the energy savings because you're actually slowing the speed of the compressor down. So a lot of manufacturers have a digital scroll compressor option, and digital scroll compressors do have some capacity modulation, which comes from separation of the scrolls. Whereas the inverter compressor doesn't separate the scrolls, it just physically slows the speed down with the VFD. So you get the energy savings, which results in less cycling, which results in more precise temperature and humidity control, soft starts on the components, that kind of thing, which gives us up to a 21.3 IEER rating, which is one of the highest in the industry for this type of equipment because of this. So some of the big takeaways for our DOAS unit, we will have the shortest lead times out of any manufacturer and of this type of equipment, pretty much guaranteed. We're generally running in the 3 to 6 week range, just depends on unit options and that kind of thing. Right now, out of a few plants, we're looking at like a week or so. So just something to keep in mind if you have a lead time critical project. There, a lot of times we're looking at jobs just based off of lead time, knowing that you're going to pay a little premium for a higher end piece of equipment, but you can get it in a couple weeks. So if there's ever a lead time concern, that's definitely something to keep in mind. But our lead times are definitely top tier in terms of when we're looking at the competition as well. Like I mentioned, we have 6 manufacturing plants across the U.S., which that really helps with the lead time thing. The closest to you guys in the Northwest would be our Redding, California plant, which is probably where most of the equipment we would be shipping out of would be. But, if Redding was backed up, we could always look at options of shipping from Iowa. It's a little bit more in freight costs, but it gives that kind of flexibility, just kind of with the diversity of where the plants are to keep lead times down and keep production strong. So part of the reason our lead times are strong also is, like I mentioned, we kind of standardize with these higher end, fully variable speed components. So those are standardized and stocked at all plants. So, we don't have a million different options for a high efficiency, low efficiency. We have just kind of this standard high efficiency option across the board for all of our unit sizes. So it helps with kind of the stocking of parts. Obviously, seamless integration with the CaptiveAire commercial kitchen ventilation equipment. We have also a big benefit is we have an in-house service network. So this is employees of CaptiveAire that are on our service team called Cast Service. And we have this nationwide team of factory trained technicians that will, with every unit, we include a startup or service design verification, SDV, we call it. So with every single unit sold, we'll include startup, and that'll be by our Cast Service network. And then they're also available if we ever needed to do preventative maintenance contracts or any sort of service work. They're available for that as well. So that's a big benefit to have them available for this. Also included standard on every unit, which I'll get into in a little bit, is our complimentary monitoring service called CastLink. So we ship every single unit with a cell module, and we pay for the cost of that cell data to allow us to do remote monitoring on the units. So CastLink is this remote monitoring software. It's a web-based software that we have access to, and we can give actually third-party login access to if you're interested in having an account. And it's a really useful tool for us to validate performance, but also if you ever run into an issue or troubleshooting kind of issues, we can pull up CastLink data and have a really good idea of what's going on with the units. So I'll dig into that in a little bit. 5-year parts warranty is standard on the entire unit. We have an optional 10-year parts warranty with a preventative maintenance contract, essentially to say we are willing to extend the warranty of the unit to 10 years if the standard preventative maintenance is, maintained. So just changing filters, cleaning coils, that kind of stuff, which is often overlooked, but that can deteriorate the life of the unit. So if that's being maintained and recorded, we can actually extend the the warranty on the unit. 25-year parts warranty on the stainless steel heat exchanger if we're using an indirect fired heater. And then we have a replacement program sort of in the works for possibly a 1-week turnaround. Essentially, if there's ever any lead time concerns, I would say reach out and we can see what options we can make work. I would say don't assume anything's impossible because we have some flexibility with a bunch of different plants and that kind of thing. So we can always see what can happen, what we can make work. So just to go into some of the specifics on the unit sizing, this is just a table showing our different tonnages. So we range down to 5 tons up to 60 tons. And that's in 4 different cabinet sizes. And the airflows listed here are kind of just general airflows that blowers within those cabinets can hit. But again, it's these selections are very specific to an application and to a location, depending on ASHRAE weather data and that kind of stuff. So we're not necessarily always going to be running 3,000 CFM through a 7.5 ton unit, but it's kind of location based. So this is just a picture of our different cabinet sizes, and we'll work on this when we're going through selections. We're always going to try to put our most competitive selection forward in terms of keeping footprint down, weight down, and ultimately trying to save cost. We have different kind of combinations of compressor sizes and different cabinets. Sometimes we need to go to a larger cabinet to hit higher airflows. And again, it's just kind of dependent on the application and what the requirements are of the given job there. So I just hit on this typically because DOAS is typically sized quite a bit different than what like a traditional rooftop unit or RTU is sized at. A traditional RTU, I think we say 20% outside air is sort of the max that they can handle just based off of their coil designs. Where a DOAS unit and our unit, we can handle up to 100% outside air. Traditional RTUs are typically running around 400 CFM per ton, where that is not necessarily the case for a DOAS. If we're looking at 100% outside air unit, and depending on what part of the country we're in, obviously the Southeast being a little bit of a hotter and humider climate than other locations, runs a much lower CFM per ton. So it's very dependent on location. So when we're working up selections, we're always going to ask you for the job site location, and we'll pull in our selection software. Will actually pull in the ASHRAE weather data just to verify. We can model it at whatever temps we want to, but we'll want to just kind of cross verify that with the ASHRAE weather data for that location, just to make sure we're kind of on the same page with equipment sizing. So this is just a very quick example of a 15-ton unit that I ran a selection for in Miami, and then a 15-ton unit that I ran a selection for in San Jose, California. Obviously, Miami is very hot and humid. San Jose is a much drier, a little bit more mild climate. So that 15-ton unit in Miami at the ASHRAE design conditions to hit around a 55-degree, 54-degree leaving air temperature off the coil was running at 2,000 CFM at 100% outside air. That same 15-ton unit at 100% outside air to hit the same leaving air temperatures with San Jose weather temperatures was running 4,800 CFM. So obviously a huge difference in airflow and design just simply based off of the location. So that's why we'll kind of pry for that location information on each selection we work up. So for the coil sizes, I don't have the 60-ton here, but as you can see, we kind of range from 4-ton or a 5-ton up to now 60 tons, and just a varying number of coil rows. Again, the idea being to pull out as much moisture as possible. And we utilize a hot gas reheat coil off the end of that evap coil to essentially allow us to dehumidify. So I don't know if everyone's familiar exactly with what hot gas reheat is. So I'll just kind of go into the basics of it. But essentially, during the refrigeration process, obviously when we're cooling on the evap coil, the condensing side or the outside of the unit is rejecting heat to the ambient. The hot gas reheat coil is a coil that essentially allows us to reheat the airstream after it's been cooled down, with the idea being, we take that probably hot and humid outdoor air, drop the temperature down, pull out moisture through the evap coil, but you can't necessarily deliver that air to the space at 50 or 55 degrees. You need to deliver it at a more neutral temperature. So that hot gas reheat coil is just utilizing the waste condenser heat to reheat that air back up. So it's dry and dehumidified, and then you can deliver it at a more neutral temperature. So the hot gas reheat coil is just a single row coil off the evap coil, and it is mounted face to face here. There's actually quite a bit more room than meets the eye, just because the coil casings are mounted up against each other. But we do get questioned on, is there enough room between the evap coil and the reheat coil to prevent potential rehydration? And we're satisfied in that regard, just because we run low enough coil face velocities, even at the maximum airflow through this evap coil, that we won't risk pulling off moisture. And there's a little bit more room between the coils than meets the eye. So our hot gas reheat logic, essentially, or hot gas reheat in general, this is just on a psychrometric chart. Just takes that, hot, humid outdoor air, cools it down to saturation, and that's when you start pulling out moisture. And you drop down to, say, 55, fully saturated. You utilize the hot gas reheat to reheat that air up to a more neutral temperature. We utilize a reheat dew point adjustment to essentially overshoot a dew point set point on when we're doing like a space control. So essentially, we're never prioritizing a call for cooling over dehumidification and vice versa. So that is just one of the benefits of the logic that we have. For heating options, we have a few different heating options. We can do indirect fired heat or electric heat. We also have heat pump available, as well as a hot water coil option. For the indirect fired heat option, our standard is an 81% efficient heater. The pictured here is actually a 90% HE indirect fired heater. We don't utilize these too often because they are fully condensing, but it's just shown here for reference. For the indirect fired, we go from 50 MBH up to 800 MBH with a 6-to-1 turn down standard, or we actually have an optional split manifold high turn down up to 18-to-1. Again, fully modulating from it's not 6 stages or anything like that. It's fully modulating between 100% output and 1/6 of that. For the electric heat side, if we're using electric heat, it's SCR controlled, so fully modulating electric heat there. And then the heat pump option is for 30-ton units and smaller, so that is available as well. For our blower options, again, no belt-driven motors in the unit. It's all direct drive fans. So we have an ECM fan standard, or ECM or a direct drive with VFD. Typically, we'll standardize with the direct drive with VFD, but we kind of depends on the static and the airflow of a given cabinet size based on what we'll select. So for discharge and return configurations, so for the discharge orientation, we can do a down discharge through the base or a side discharge out this side panel here. If we want to, it's not really field configurable. We'd have to order it correct from the start, but it is an option, and it can avoid us having to use like a plenum curve or anything like that. On the return side, again, a lot of times these are 100% outside air units with no return, so a return might not be applicable. If the unit does have a return, the return would be through the base or through the side here. And then this outdoor air intake is a louvered intake standard designed to prevent entrainment of wind-driven rain. And that works well. We do have an optional hood if needed too. So we do have a powered exhaust option and barometric relief. Again, the powered exhaust this would be if the unit does have a return. So we have a few different options, and we'll kind of look at it case by case depending on the job. Sometimes a separate exhaust fan makes more sense than trying to get an exhaust through the unit. We have this sort of simple pressure relief exhaust, which is just a set of a few ECM fans. We also have a powered exhaust module, which utilizes our energy recovery wheel, which I'll get into that option a little bit without the actual energy recovery wheel. So it's a whole nother kind of module mounted on the unit with a direct drive plenum fan. Or we can utilize this barometric relief here as well. Our damper it's a mixed, so it's an outdoor air return air damper. It's a single damper assembly for the outdoor air and return air. So the bottom portion is the return, if we have a return, and the top portion is the outside air. This is the standard damper assembly for all units, whether they have return or not. But it's a really high-end damper assembly manufactured by Ingenia out of Italy, and there's no play in the gears. It exceeds the ASHRAE Class 1A low leakage standards, and we utilize a Belimo actuator as well. For filtration, our standard filtration would be a 2-inch metal mesh on the outdoor air intake, followed by two 2-inch racks, so a 2-inch MERV 8, 2-inch MERV 13. Those two 2-inch racks can actually be replaced. We can do a single 4-inch rack. We'd have to order it this way from the start, but it can be a single 4-inch MERV 15 or a 4-inch HEPA is an option as well. So this is actually just kind of a good cutout of the unit to sort of see the airflow configuration. So the outdoor air would be coming in from the left side through the filtration here, and then into the evap coil, into the blower cabinet, discharge down into the heater cabinet, and then either down to the base or out through the side of the unit towards us as sort of the general airflow path. And then if there was return air, that return air would be coming up through the base here and be mixing with that outdoor air to be brought back towards that evap coil there. We use intake and discharge averaging sensors, particularly on the discharge side. It's really hard to get an accurate discharge temperature reading right off of a heat exchanger on the heating side. So because there can be hot spots and non-uniform airflow, so it's hard to get a really exact reading. So we standardize with a factory-mounted discharge averaging sensor, which has proven to be pretty accurate and doesn't require any sort of downstream field mounted temp sensors, which is convenient. Just one less thing to get missed during install. We also do that on the intake side as well for if we're doing partial recirc, just to give a more uniform intake reading. Our stainless steel slope condensate drain pan, that is standard on all units, and we have a condensate overflow switch on that standard as well. Our standard unit construction is a little bit different than maybe some other manufacturers. It's a galvanized G90 double wall, so it's a interior and exterior. All of our cabinets are 2-inch R13 closed cell foam. Our smallest cabinet, size 1 cabinet, is actually 1 inch, but still double wall. And we've been utilizing galvanized G90 for rooftop equipment for years, and sort of see this as our preferred approach for corrosion resistance, just given sort of some of the challenges with painting and seeing paint chip and creating kind of weak spots. That said, we do have an option to paint the cabinet if needed. It's not something we would necessarily recommend for corrosion resistance, but I know that sometimes it is required. So we do have an option to paint. The only challenge is it has to ship from our Iowa plant. So there's always a little bit of extra freight cost for that, and obviously the cost of the paint as well. So it is an option, and we can always look at options for that if needed. So some service-friendly design features. All of our doors are removable hinged doors. We have an insulated electrical cabinet, optional convenience outlet. The electrical cabinet has an LED light strip in it, standard. So when you open the doors up, it turns on kind of like a refrigerator. The blower door will have a door tamper safety switch as well. For controls, I guess we can kind of manage anything on the controls side. We manufacture all of our controls in-house. We have some flexibility in that regard. But kind of depending on the job and the sequence of operation and the requirements, we're pretty flexible on what we can make work. We have the capability to modulate damper and blower with field wires, switch, preset speeds or positions, manual control. We can take 0 to 10 volt inputs. We can do static pressure controls or CO2 controls. For temp and humidity, we can do a discharge. We can do a space control. We have Title 24 economizer compliant options, occupied unoccupied scheduling. Regarding BMS integration, we have the capability to do BACnet, MSTP, or IP, LawnWorks, or Modbus RTU. And then we have CaptiveAire CFM monitoring as well. So yeah, if there were ever questions about what we can or can't do, we can. The vast majority of the time, we can make something work, and we have a lot of capabilities, I would say, on this side. So, just some general options that are available. We have an E-coated coil option, so that would be for the evap, condenser, and hot gas reheat for kind of coastal applications. So we have those coils stocked at our plant in Reading. Condensing coil, hail guard, clog filter switch. All of our units are Miami-Dade wind certified standard. So this isn't an additional hardware component, it's just a standard certification of our units, which is really probably the highest wind certification that you could need. It's kind of a testament to the construction of the unit and the durability of the unit. The testing is that they fire 2x4s at all 4 sides of the unit, and not necessarily in hopes that the unit will operate fine after getting a 2x4 through the condensing coil, but more so just to show that there's not shrapnel coming off the unit. So I think we have one of the highest Miami-Dade wind certifications, and I think we're one of the only standard package unit manufacturers that actually has this certification on all of our units standard. We have seismic curb options and standard curb options and plenum curb options in-house as well. Freeze stat, overheat stat, load line reactors, and then we have low ambient and extreme low ambient cooling operation options. So that would be for maybe more specialized type applications that we would be utilizing that. So this is called our HMI, or human machine interface. So one of these is factory. It's an LCD screen with 4 touch buttons. One of these is factory mounted in the controls cabinet standard on every unit. And then one will ship loose and can act as a space temperature and humidity sensor if you'd like, or it could just be installed in a manager's office to act as sort of an interface with the unit without having to go up to the roof. We also can daisy chain up to 4 of these to act as space averaging sensors as well. So convenient kind of to have in the space. So the CastLink monitoring software that I touched on, this is really a useful tool for us in just validating performance. But if there's ever any issues, the majority of the calls that we get about issues with the units are oftentimes related to settings that either were adjusted or just not set properly. And if there is settings adjustments that need to be made, we can work through that with you or your customers, and we can give this, we can give even third-party logins if needed, but it's all web-based. It's castlink.com. And again, that cell module ships with every single unit, and we cover the cost of that cell data for the lifetime of the unit as of right now. So we get a ton of valuable information from that as a manufacturer. So that's made it worthwhile. And this is probably one of the most powerful tools, I would say, of the entire unit, just because I can see at any unit right now exactly what's going on and know if there's an issue exactly where to look. So if there is a troubleshooting problem that we need to go on site to address, we know exactly where to look, and ahead of time we can get the correct parts or just know kind of what we're getting ourselves into if there ever is an issue. So this is sort of the interface. You can overlay all sorts of different points, and you can zoom in and out, and you can track data historically up to a few years, but you can put over temperatures, humidities, refrigeration pressures, blower speeds, all that kind of stuff. And you can overlay all that data to see what's going on. You can look at active faults, that kind of thing. We also have a dedicated engineering team behind CastLink that is available to do these kind of reports. So if you have a chain account or something along those lines, they're available to create these kind of customized reports for how the equipment is performing and energy usage and space temperature and all that kind of stuff. We have a dedicated support team that helps kind of monitor all the units throughout the days. And we, again, as I mentioned, we can make settings changes remotely if needed. Obviously, kind of working with the site or working with you guys to make those changes. So this is there's a few examples I'll just go through quick where we get a call and someone says our space is overheating, which that could mean one of a million different things, and you don't really know what's going on. So these were all just space overheating calls, but we don't know exactly what they were for until you pull up the CastLink data. So this one was every time a call for heat would come on, the discharge temperatures for that unit would spike to like 95 or 100 degrees. So we weren't getting heat modulation, which was overheating the space. So it turned out that the low fire setting on that gas valve was not set properly. So we weren't getting the modulation. So once that was resolved, we were able to get those space temperatures back into line with the discharge temperatures not being spiking there. This one was a lab that had a lot of high internal gains, and we were able to just essentially make some economizer settings changes remotely that were able to essentially bring the temperature of the lab down. So we were able to just bring in more outdoor air ventilation into that space over the course of a few days and drop the temperature of that lab because of that. This one, which is probably not an issue really anymore, was there was a downstream duct mounted temperature and humidity sensor was installed on like an elbow of a duct, and it wasn't giving an accurate reading. It was getting kind of some temperature spikes, which the unit wasn't able to control to an exact discharge temperature because of that. So they relocated the downstream duct temp sensor, and the discharge temps kind of came into line and started looking a little bit more consistent. The last one here was just we were getting readings that weren't making a ton of sense, and we were seeing outdoor air temps showing like -50, which we knew was not accurate. Which when we get those kind of readings, we know sometimes that the thermostat was miswired, and it turns out they just miswired 2 of the wires on the thermostat. So they got those resolved, and all the temperatures kind of came back right into range as expected. So those are just some quick examples, but CastLink has been kind of a lifesaver for us in terms of knowing exactly what's going on with equipment that's in the field and able to really get into the nitty gritty of how the unit's operating and performing. So as I mentioned, we have our own internal service network called Cast Service. They include SDV or Service Design Verification, which is essentially startup for every unit. So every job that we quote will include by default the startup to make sure that equipment is running and operating correct from the get-go. So they're available also for service work, and we also have a technical support team to assist them and or anyone else. They are all, like I mentioned, employees of CaptiveAire and have kind of extensive training, so they know the equipment in and out, which is really helpful to make sure things are kind of set up properly and diagnosed correct. So this is our energy recovery wheel option. So this sort of left half here is the energy recovery wheel. So I don't know if that's something that we see a ton, but it is an option that we have available, and we use Air Exchange as our wheel manufacturer. So this is a sort of a modular add-on to the DOAS. So it's not a standalone ERV. This is sort of its own pre-treat, or it's a stage of heating or cooling before the air enters into the DOAS to essentially recover, energy from the exhaust airstream if you have the exhaust kind of running through the building. So We have some advanced controls for wheel speed control and frost protection on that wheel as well. So it is available as an option. It does add a little bit of lead time and some upfront cost, but I understand it's a lot of times required by code, so it is available. Just a few other features. We have 575 volt options for Canadian jobs. Low ambient and extreme low ambient cooling options are something that we have available, as I mentioned. We have a high ambient option as well, which is when we're looking at outdoor air design temps that are in the 105 to 110 Fahrenheit range. Our unit compressor can run into what we call a throttling state, which essentially is to ramp down the compressor speed to prevent us from going out on a high head pressure in those really, really hot days. And the idea of the high ambient option, which is a physical hardware option, we actually use beefed up condensing fan. So we use a higher output condensing fan and a slightly lower factory charge. So we would essentially prevent the unit from going into this throttling condition and allows us to essentially not ramp down the compressor at peak heating or peak cooling conditions. So kind of case by case, again, based off of the weather design data of a given location. If we're looking at an area that has like a 105 to 110 ambient design, that could be something to consider. Intake and discharge averaging sensors, as I think I mentioned before. We have a newer option that's called essentially our heat only option. And so it entirely removes all the DX cooling components from the unit. So it's our unit. So you still get all the same benefits of kind of the higher end components and construction of the unit, just without the DX cooling portion of the unit. So essentially the unit becomes sort of an air handler in a way, and we can utilize any of the heat options. So we can do gas, electric, or hot water coils. We also now have the option to do a chilled water coil in this unit paired with any of those as well. So could be a good option for buildings that have sort of chill water loops or hot water loops, but is available now fully. So we have a unit screening option. So this is attaches to the frame of the unit. There's no roof penetrations. If there's line of sight requirements or any issues in that regard, this could be a good option. And then just some latest features. We have upgraded controls for airflow monitoring on the supply and the exhaust side for ERV. We have some upgraded pressure controls. Some of those higher turn down heater options are available. Single phase power options. So we have single phase power units for 12.5 tons and smaller. And then we have that grow house logic with the extreme low ambient cooling options, some more sophisticated controls on that side. So the latest features, kind of hit on most of these already, the hydronic hot water heating, chilled water cooling coils. We have that 60-ton unit that just came out, and then a size 3 cabinet 30-ton, which is essentially just putting more tonnage into a smaller cabinet for more humid and hot climates that are running lower CFM per ton. The last one is an OSHPOD certification, which we don't have yet, but we are working on currently. So that was sort of the main points. Obviously, I'm available for any questions, but thanks for listening to the spiel and for the time, and happy to stick around for a little while to answer any questions. So.
Thanks, Ian. We appreciate your time. And like I said, I'll send out my contact information for everyone to shoot me questions that you have. We'll be happy to get those answers, work up some sizing for you all, and also blast out a brochure so that everyone has it. So thanks again for joining. We appreciate your time. Thanks, Ian.
Yep. Thank you all. Appreciate it.
Bye.
Thanks, Ian.
No problem.